recording because I forgot to do that for those who are here. 11 is one of the interesting, tricky ones. I went after this one like 4 different ways before I figured it out. Honestly, in 11, I would have started on the right only because I can do something with the right and I can't really do anything with the left. This is, if I start with the right-hand side, the only thing I could think to do with cotangent is make each of them 1 over tangent. You could have done cosine over sine, but that doesn't really make sense given that the left side has tangents in it. And then this is one of my favorite complex fractions like we just talked about. So if I don't like double fractions, my rule of thumb is to take all of that and multiply by tangent over tangent. And if I'm distributing that top and bottom here, that's going to give me my answer. Tangent theta, on the second one, the tangents will cancel, so I have -1. On the bottom, it'll be tangent theta. The second one, the tangents will cancel, give me +1.
Okay.
Yeah, that one, I mean, if you try to change it to sines and cosines and all that business, it makes life very, very difficult. But, because trust me, I tried. Other ones on this page?
Could we also do 12?
Yeah. 12, I would have started with the left-hand side. Because the answer is in terms of sines, I might have, well, here's 2 things. One thing, either the top or the bottom is a Pythagorean. Which one's a Pythagorean?
Bottom.
The bottom is. So I would have started with that. 1 plus tangent squared changes into secant squared. Is that correct? Yes. Then I would have changed everything to sines and cosines. So tangent is sine squared over cosine squared. The secant squared is 1 over cosine squared. So using kind of the complex fraction thing again, I could have taken everything here and multiplied it by cosine squared, top and bottom. If I do that, that's going to give me cosine squared minus sine squared over 1, which I really don't have to write anymore. So we're getting closer, but if I look at my answer, I just want sines. So that tells me I should take out my cosine squared and substitute something that has to do with a sine. So according to our Pythagorean identities, what can I do with the cosine squared?
1 minus cosine.
I can make that minus sine squared, and 2 minus sine squareds turns into 2 sine squared. I've also seen people here say that this is the same as cosine of 2x, one of the double angle ones, and so is this answer. So kind of use that as a go-between, which you can as well. Other homework questions from y'all? We're somewhat okay. I feel like these are all very much like the medium level proofs. I'm going to show you guys some of the harder ones Thursday when we talk, just to kind of discuss those. And hard doesn't necessarily mean like you're going to have no idea how to do them. It just means they're going to combine more things, more algebra, more steps, more identities, basically. So what we're going to talk about today is our last set of identities then, if no one has any more questions. The last ones that we are going to be using are the sum and difference identities, and I'm going to go ahead and pull those up here. So the sum and difference identities we are never going to memorize. So for your test, you're just going to have to know the basic Pythagorean and the double angles. And that's also for your quiz. So what I will do is kind of like what was on the first quiz, is give you boxes to fill those in. It'll literally be this sheet with just boxes in place of these as your front sheet. You will have the sum and difference ones down here, And we are not really going to use the half angles and the other useful ones. If you find them useful, then be my guest, but I don't use those. So really kind of cut the sheet off here underneath the sum and difference ones and keep going up. So really here's the purpose of the sum and difference identities. And I am going to go, I'm going to flip forward in our notebook a few pages. If you have yours and want to look at them with me, you can. But this is page 215. So the purpose of the sum and difference identities is because of the question that you see here under number 1. Does cosine of 30 degrees plus 60 degrees equal cosine of 30 plus cosine of 60? Well, if you think back to your chart that we used back in unit 6, cosine at 30 degrees was 1/2. Cosine at 60 degrees was root 3 over 2. So the only thing I could really do with that is make the top over the bottom common denominator. But if I do the left-hand side here, 30 plus 60 would have to be added first, right? So this makes cosine of 90. What's the cosine at 90? 0. Are those two things equal? No. So what that tells me is that as much as we want to, when you have something set up like this, you can't basically distribute the cosine to both terms. So that is the purpose of the sum and difference formulas. So you'll notice that rather than taking, for example, down here in the box, the sine and distributing it to both the A and the B, because we just said that's not possible, you have to use this formula. So it's not a basic distribution. There are just these formulas. So we're going to practice by doing a couple questions with this. Some of this is going to bring back a little bit of the chart. So just get that in your head there. The way that you're going to see these is kind of like on the back page here, 216. On question 4, verify the following identity. And it's the same thing. It's like a proof. Start with the more complicated side. So I would start with this hand. And because I see inside the cosine term a plus sign right here, I'm going to go look at my sum and difference identities and see which ones I can use. So I'm going to erase this real quick. Go over to your trig identities formula page here, and we're going to look for the one that looks like this. So notice you have a sine with a plus, you have a cosine with a plus, a tangent with a plus. You have sine with a minus, cosine with a minus, tangent with a minus. So what this tells us is the formulas take care of the minus signs in here. So when I go to do the alpha and beta or the A and B, I'm not worried about the negatives there. I'm just worried about whatever the exact values are. So basically what we're seeing there, because it was a cosine with a plus, I'm going to go ahead and use this formula here to expand this. These always look a little bit messier before they look nicer, just kind of FYI. So going back to that, I see that I have a cosine with a plus formula. Excuse me, too many things going on this page. All right, so I have a cosine with a plus. That means that I'm going to use the formula cosine alpha plus beta equals. And this is just copied down from your formula sheet. Did this have a plus sign in between these or a minus sign? I forget. Like I said, I never memorize these.
A minus sign.
Minus sign, okay. And it was sine alpha, sine beta. All right, so that's the formula I'm going to use. Using that formula and using that, excuse me, to expand this, I have to use pi as my alpha and x as my beta. Okay, so I'm going to take this and using that formula, that is going to expand to cosine pi, cosine x, minus sine pi, sine x. So anywhere I see an alpha in this formula over here, I'm putting a pi. Anywhere I see a beta, I'm putting an x. And that is the expansion of cosine pi plus x. Anyone have any problems with that or where we got that from? Okay, so from there, any ideas as to what we can do with this? Where can we go from here? Anyone remember what we can do with those two things that I've underlined, cosine of pi and sine of pi? think about your chart. Okay. We have your chart with your cosine, sine, and tangent values. Okay. So just thinking about cosine, cosine went from 1 to 1/2 to root 2 over 2 to root, 1 to root 3 over 2 to root 2 over 2 to 1/2 to 0, right? So pi, where would pi have gone? What would pi have gone with in terms of reference angles? Anyone remember that?
0.
It would go with 0, right? So these were my reference angles up at the top. Pi would go with 0, but pi was all the way over on the left-hand side. So that means the cosine at pi, what value can I put in place of that?
-1.
-1. And what value then can I put in place of sine of pi?
0.
0. Now what does that do for me? Actually finishes up the problem. Because anything times 0 cancels out. And that just leaves me negative cosine x, which happens to be my right-hand side. So these, once you expand them, go very, very quickly. You plug in the pi and the pi over 2 or whatever values that you're working with, and that is literally it. So these are not going to be very, very complicated ones. I just want to do a couple more examples with those because they're just different formulas and it's getting comfortable with using them. Let me see if there's any other ones. There weren't a whole lot like in our note sheets. So I am going to just like pull up a blank sheet here for me to work on and give you guys a couple more examples to do with these. And then we will be done.
Miss Leininger, why
Yep.
was it -1?
Why was it -1? Because if you think about where pi is on the unit circle, remember that cosine is an x value. Pi was all the way over on the left-hand side where the x's are negative.
Oh, okay. Thank you.
Yep. Let's do another straightforward one like that one. We will do prove sine of x plus pi over 2 is equal to cosine of x. So first off, I'm looking for the correct formula for this. It's a sine with a plus sign in it. So if I am going to go through that process here, I'm going to look for the sine formula in my trig identities. I really should have brought myself a page with that because this freezes up my computer. Using x as my alpha and pi over 2 as my beta, what is that going to expand into? Anyone have their formula sheets?
Sine, what is it? Sine x times cosine pi over 2 plus cosine x times sine pi over 2.
Okay. And this is, he's looking at this on the formula sheet. The formula sheet says sine of alpha plus beta is equal to sine alpha, oops, that's a bad alpha, cosine beta plus cosine alpha sine beta. So literally plugging in x where alpha is, pi over 2 where beta is. Then these all kind of follow the same process. If they have pi's in them, you look for the pi values and replace those. So thinking about your chart again, at pi over 2, what was the cosine value?
0.
0. And at pi over 2, what was the sine value?
1.
1. And once you plug those in, the first term cancels out. And you just get cosine x. I do want to do one that looks a little bit more complicated because there's no pi values, but they can still work out. So this one would be, let me actually pull up my trig sheet to see if I can get, all right. No, can't do that right now. Okay. Let's do as another example, sine of alpha minus beta over cosine alpha cosine beta, we're going to prove that that is equal to tangent alpha minus tangent beta. So obviously start with the more complicated left-hand side. Is the top or the bottom of that fraction one of our formulas?
Top.
Top. So I'm going to go ahead and find that formula on my sheet. And this is in the exact form that it's in. So you're literally copying down the expansion of that. So what would be the expansion of sine alpha minus beta?
Sine alpha cosine beta minus cosine alpha sine beta.
Okay. And we said the bottom is not one of those things right now because there's no plus sign. It's just cosine alpha, cosine beta multiplied together. From here, what do you think is the best way to proceed? Because I have something I'm thinking of. I
How
would
about it?
look at this as two separate fractions. So I would go ahead and split it up into these two fractions. So once those are split up, what's going to happen in the first fraction?
Just get rid of cosine beta.
Cosine beta, and then sine of something over cosine of something, no matter what that something is, makes what?
Tangent.
And
Tangent of that same something. Same thing in the second one. Cosine alphas cancel. Same thing, sine of something over cosine of something else makes tangent.
Tangent of that other thing.
So these are going to always,
wow.
like when they expand out, you're going to be like, there's no way I'm going in the right direction because this is messy and this is nasty. These all tend to look very nasty within like a step or two and then simplify down very quickly. Okay. Let us do maybe just two more of these and then we'll talk about what's the homework. I don't want to keep you guys on here too long. Let's take a look at this one. Tangent of theta plus pi over 4 is equal to, whoops, not sine, excuse me. Cosine of theta plus sine of theta over cosine theta minus sine theta. This one is a little bit tricky as to like where you think you should start because we always say the more complicated side, which most of you would probably argue that the right-hand side is more complicated. You could try to go after that. It's a little bit hard to replace a single cosine or a single sine. So I honestly, now that we know we're using these sum and difference formulas, I would look at this as a sum and difference formula with that being your alpha and that being your beta. We have a formula for tangent as well that we can use to expand. So what does it say that we can do with tangent according to our formula sheet?
So it'd be tan theta plus tan pi over 4.
Well, you can't do that distribution like that. Look at your sum and difference formulas for this one.
That is the sum.
That is?
That's what it says.
Oh, okay, sorry. That's not it though, is it?
Oh, no. Then it's over something else.
Okay, perfect. And it's over what?
1 minus tan theta times tan pi, or pi over 4, yeah.
Okay. So that's our expansion of the left-hand side. Again, looking a little bit nasty, but at the same time, it's looking a little bit more like the right-hand side format, only in that there are two things added together on the top and two things subtracted together on the bottom, which helps me think I'm headed in the right direction. Using the things we've talked about here so far, what could we do from here?
The values from our chart for tan pi over 4.
Yes, anytime we can do values from our chart using the pi's, I would get rid of those early on. What is the tangent at pi over 4?
Right, because it's
Is it 1?
Yes. So for both of those places, I'd go ahead and put in 1, which I really don't have to do anything with that right now on the bottom. Looking even kind of closer to what we were talking about, except my answers are in terms of sines and cosines, which kind of leads me to my next step. What would you then do?
Turn them into sine over cosine.
Turn each of my tangents into sine over cosine. And this is kind of going right back to what we were talking about on the homework page. When we have complex fractions, the easiest way to get rid of complex fractions is to take everything here and multiply it by what in this case?
Cosine?
Cosine over cosine. That does kind of come up a lot
Jeez.
in these. You're maybe starting to realize that. If I distribute that cosine to the first term, it's going to cancel with the sine over cosine and just give me sine plus 1. And then distribute on the bottom cosine. Oop, not 1, excuse me. Sine plus cosine. There we go. And then cosine minus sine. Okay. So those formulas aren't really that bad. And again, you don't ever have to memorize them. So just being able to plug stuff into them is kind of the way you want to go with those. Any questions over the new identities we've talked about? That being said, your homework kind of skips around for that purpose. So some of your homework, check my PCA for these still, always. Some of your homework is on these sheets that have the sum and difference identities. I had to pick around like which ones are good ones and which ones are not. So that's why the list on the homework is interesting for that. Also, for part of your homework, if you flip back to, not that page, this page, 209, I've picked out a couple problems on page 209 for additional proof practice for kind of the middle level. A lot of these that I've picked out have to do with factoring. It tends to be stuff that we miss. We miss difference of squares, or we miss just regular factoring, honestly, can be part of this as well. So if I go to, let's see, I'm going to stop sharing this. If I look at my PCA here, let me try to share this.
Do you want me to tell y'all I have it pulled up?
Yeah, I'm actually going to share this so that y'all can see it too. This is like what I have on the bulletin board now. There's a link to a video on where to find stuff on Canvas if you need help with that. There's the Zoom meeting schedule up here. And under here, I have like the link and everything because it's the same Zoom meeting room every time. And then I've put the Zoom meetings on the calendar as well. For homework, let's see. I will pull that up for you if my computer is working. Not that, please. Where is this and why is this not working? I love all of this. Are y'all all able to find stuff for my class, generally speaking?
Mm-hmm.
Okay, not having too much of a problem. So our homework, why is something labeled 10.1? Oh, it's not due till May. Look at me. All ahead of the game. This is homework 8.4, I believe. Yes. So here's kind of the list here. Page 209, 7, 8, 13 through 17. And then 219, 4, 5, and 9. 224, 10, and 11. So I've kind of tried to pick and choose that second section there. 219 and 224 are both on the sum and difference identities. And then this first section is that page I was looking at with you. Just for like future reference, because I know some of you really like to practice extra stuff. Let me just show you this in here as well. This is the page I assigned part of for your homework. I'm never going to assign the rest of it, but I can help you with any of those if you need them. So this is a great place for extra practice, but even better The back page is all very similar problems. There's 20 of them. And if you keep going in your notebook, these are the solutions to all of them, to the sample problems. I don't know if I have those in the right order. So it's good to be able to like check your work if you need to. So there's those, the extra practice if you need them. Anything else y'all need from me at this point? We're all okay? The quiz 8.2 is going to be, I think, Thursday and Friday this week. I'm going to not do too much, like well, I don't know how it is for every other class. It seemed like that classwork page I gave you before the quiz took a long time in between doing the stuff that we did on the live and then doing the practice page and then doing the quiz. It was kind of a lot. So I'm going to stay away from kind of the classwork stuff. There is a harder proofs group activity that is what I'm going to work through on Thursday, along with talking about the test. So if you want to look at that in advance, it's 4 questions just to get an idea of where to go. That's what we're going to be working through live on Thursday. And then you will have your quiz for later. Trying to figure out another quiz format. I don't know what to do at this point. I'm currently dealing with photo math and cheating and stuff like that. And I don't know where to go from here on that one. Not necessarily people on here. It's really hard for me to grade 56 quizzes when every other one of them has something random on it that I know people didn't come up with. So I don't really know what we're going to do from here, but we will figure it out. So I'll let you know how the quiz format's going to go for Thursday, and we will go from there. If y'all need anything from me, let me know.
Thank you, Miss Leininger.
Here's Leininger.
Y'all have a good day.
You too.
Bye.